Okay, so we will see probably the last phase in the calculation of surface area. So calculation of surface area of a 3D object, and that surface area we will see for the sphere, and that is through pure spherical coordinate system, not including the Cartesian coordinate system. So that is the idea, that we don't want a Cartesian coordinate system, and we will do everything in a spherical coordinate system. So that is the concept that we will see now. So everything in the kind of a spherical coordinate system. Okay, so what we have finished, right? So we saw the Cartesian coordinate. So in Cartesian coordinate, if we see, then we have x-axis, y-axis, and z-axis. If that is the case, the first we saw, if it is x-axis, if this is x-axis, this is y-axis, then if I have a circle, x-axis, y-axis, and if I have a circle, then what is the perimeter of the circle? Then we saw the perimeter of the circle is nothing but length of the boundary, length of the curve. So if I want to calculate the length of the curve, then first we calculate the position vector. If I take any point on the circumference of circle from center is origin. If circle center is origin, then we draw a kind of vector to point P. Okay, so we started the discussion with if I have a circle and it is centered at the origin, if this is the origin, then this is point P, then this is the vector. So if I have a vector equation, so vector is nothing but it has x component, y component, component, fx component. So if I have a vector, then what is the change in the vector that is seen if I change along the independent component, dp by dx. If I have dp by dx, then dp by dx is nothing but the velocity vector. If p is position vector, dp by dx is called velocity vector. So if this is p, then velocity vector is tangent to it. Everywhere it is tangent to the p. So that's what we saw. If I have velocity vector, then there is a velocity vector. It is a vector. It has three set of algebra. One in I direction, one in j direction, one in k direction. In this case, two set of algebraic equations. One in I direction, one in j direction. But curve length is only one. It is not in I direction or j direction. If there is a curve length, then that is single, not I direction, or curve length has no direction. So we calculated the magnitude of dp by dx. Whatever magnitude we are seeing, that is the magnitude of the velocity vector. If I integrate it back, then instead of getting back the position vector, I get the way position vector is traveling all through the curve, that traveled length I am getting. Like if I have a starting point, from here if I have a velocity algebraic equation, if I integrate velocity algebraic equation, I get back the length, distance. If I have distance by time, kilometer per hour, if I integrate it with hour, then I get the kilometer back. So if I have a velocity along the curve, that is dp by dx magnitude, if I integrate it, then I get the length. So dp by dx magnitude integration with dx, and then where x varies from -1 to 1. So where I took care of the circle. The circle equation came inside the P1 vector. Now in 3D plane, we have XY plane, we have X axis, we have Y axis, we have Z axis. Means X axis, Y axis, and fxy. Z is function over X and Y. So there we saw that dp by dxy. If I have a kind of a sphere, if I have a kind of a sphere, if I have a if I have a sphere, if I have a sphere, then sphere is centered on the origin. Sphere is centered on the origin. If a sphere is centered on the origin, then any point P has a vector equation. Now, dP by dxy plane. If this sphere is centered on the origin, then there is a xy plane. If there is a xy plane, then half hemisphere of this sphere is above the xy plane, half is below the xy plane. This is what we saw. Now, if I see the xy plane, the intersection of the sphere and xy plane, then it is a closed circular region which has a boundary. So that is one scenario we see. If I take any point P on the sphere, then dP by dxy plane, dP by dxy plane. Earlier we took dP by dx, x with independent component. Now here there is one independent component, that is xy plane. XY plane contains two independent components, y-axis and j-axis. But dP by dxy plane. If I calculate dP by dxy plane, so that is becomes a velocity surface. Earlier we had velocity vector line. Now we have velocity surface vector. So velocity surface vector dP by dxy plane is nothing but the tangent at a tangential surface now. Tangential line converted to tangential surface now. So there is tangential surface everywhere. So if this is a tangential surface, then tangential surface everywhere. So this is dP by dxy plane. What is dP by dxy plane? Is dP by dx. dP by dx is a vector. dP by dx cross product of dP by dy. Now dP by dx, what is P? That is I, that is xi plus yj plus zk, or xi plus yj plus fxyk. dP by dx is I plus fx, dfx by dxk. dP by dy is j plus fyk. Now if I do cross product of dP by dx, dP by dy, then that is nothing but dP by dxy plane. This is what we saw. Now, if that is the case, then cross product would result in minus fyi minus fxj plus k. Similarly, we calculated the magnitude of the velocity vector. Here again, we will calculate the magnitude of the velocity vector. So, if we are calculating magnitude of the velocity vector, then that will result in fx square plus fy square plus 1 square square. Now, if I have the magnitude of the velocity vector, velocity surface vector, if I integrate with, integrate with the xy plane, I get the complete surface. Now, what is the xy plane? So xy plane can be Cartesian coordinate, or now xy plane, where xy plane, the set of x is in a circular region, closed circular region. So closed circular region is the xy plane. Means if this sphere is intersected with, if the sphere is centered on the origin, then xy plane cuts the sphere in the half. In the half, it cuts the sphere above a space hemisphere and below a hemisphere. Now, the xy, the set of xy, only they are limited now to the circular closed region. So, if I say that if I have a square root of fx square fy square 1, and then integration with the dxy plane has set of xy value in this circular closed region. Now I have to integrate it over the, I have to integrate this over the full circular region to get the kind of net surface of the sphere. Then where is net surface equation? Net surface equation is in fx and fy, where fx is dfxy by dx, fyy is dfxy by dy. Now fxy fxy is a algebraic equation. dfxy by dx is algebraic equation. dfxy by dy is algebraic. That algebraic equation takes care of the sphere algebraic function. So this is what the scenario is. Let's calculate the surface area of a cube. If it is a cube, then if I calculate the surface area of 1, then I can multiply it by 6. So if I take the top surface area, the equation of the top surface area, that is fxy over xy in the xy plane. So this cube is centered at the origin. So if height of the full cube, height of the full cube is a means one side is a, then this height is a by 2. This height is a by 2. Left side a by 2, right side a by 2. Now I have to do, so what is equation of the fxy? So fxy equation is a by 2 because everywhere it is a by 2. The fx equation is a by 2. Now fx square dfxy by dx fy square dfxy by dy. So it is fxy is a by 2 constant. Fx and fy both are 0. If both are 0, then it will turn up as the square root of fx square plus fy square plus 1 is a square root of 1. So 1. Now we have to do integration with the dxy plane. Dxy plane is not a circular region. It's a full plane xy plane confined in a cube area. So xy is a confined in a cube closed region. If that is the case, then dx dy. So integration of dx minus a to a minus a to a, that is a, dy minus a to a, that is a square. So one side area is a square, 6a square. So this is the way we can calculate the surface area in pure Cartesian coordinate. Now we will land up in pure spherical. So we have talked about calculating the calculating the sphere surface area when the dA, what we are integrating with dA, here dA is dx dy, dxy plane. Integration of a square root of fx square plus fy square plus 1 with respect to dxy plane. So dxy plane, if I am calculating for the cone, paraboloid or sphere, the intersection on the xy plane is a closed spherical region. If closed circular region. If it is a closed circular region, then d of xy plane what we are taking, that we can take in polar coordinate. If we take in polar coordinate, then the limit would arise. Polar coordinate has two independent variables. One is r, and one is theta. Means if I have a circle, so if I have a sphere and a sphere is centered at the origin, sphere is centered at the origin, means half a sphere, half hemisphere of the sphere is above xy plane, half hemisphere of the sphere is below xy plane. Where this intersect the xy plane is the closed circular region. That closed circular region is this. This is the closed circular region. If this is the closed circular region, then this is the, if this is the closed circular region, then if I tilt it, then this is xy plane. This is xy plane. If this is xy plane, this is the circle. Now there are kind of, if this is closed circular region, then there are two independent components. One is radius. Radius in a sense, if I take the full surface area, then there is a radius which grows from 0 and it touches the full radius. If full radius is a, then there is a r that starts from 0 and touches full a. Now this radius, it rotates full 360 degree. Radius full rotates 360 degree. If that is true, then the angle of the rotation, that is variable and radius is variable. So there are two independent components called radius and angle. So now if I take the kind of the way it is there in the book, so we'll talk about it. Two way of doing integration. One is through approximation and one is pure algebraic integration. So pure algebraic integration, if I talk, then I have to find d collection by d independent component. Like a person is walking 5 kilometers per hour, then hour is independent component. Hour is time is not dependent upon anyone. Time is keep on changing. So if time is independent component, then person is collecting how many kilometers per hour. So if I have a algebraic equation in terms of kilometer per hour, then if I do integration of this algebraic equation, whatever it is constant or it is in some equation of t is the x-axis, hour, with the integration with the along the t-axis, integration means calculating the area. This is pure algebra calculus. One is algebra calculus, one is approximation. Then I get the net kilometer per hour. If it is a graph along x-axis, that is hour, if I calculate the area, I get the pure integration, that is kilometer. Now, if I go with the traditional, let's go with the traditional way. I mean, let's go with the bookish way. So, bookish way will call it that if I take an infinitesimal small area, dA. What is dA? dA means if this is r, if this is the radius, suppose this radius is here only. Okay, radius is here only. Radius is here. It is not touching the circumference. Radius is here only. Now, if I make a small increment in radius, if it is r, the radius is r, not a. A is full radius. If radius is at any moment is r, if I make a small increment, that is dr. Okay. Now, this radius, if I make a small increment in angular fashion, not dr fashion, not along the circumference, not towards the circumference, in the arc fashion of the circle. If I rotate it, then I rotate angle d theta. Then what is the arc? If I rotate, then there is an arc. Or if I go along the circumference, there is a length. If this arc and this length, if I multiply, then that is the dA, the infinitesimal small area. This is the way you will find everywhere in the book. Our way is different. We follow the actual calculus, that is the integral calculus, not this approximation, but whatever. People understand through this way also. So, how it is a dA, but anyway, if it is a arc, if it is a arc, then full parameter is extension of this arc one. If this is a small radius is there, then full radius is increment of this radius one. So there are two orthogonal components. One is arc and one is radius. Radius and arc, if you see closely, they are perpendicular to each other. Anyway, if arc is one component, so arc, how much is the arc for the d theta angle? If there is r radius, then r d theta is the length of the arc. R d theta. R d theta into dr is the area. R d theta dr. Now I have to integrate d theta with full. So theta 0 to 2 pi. So r 2 pi. 0 to 0 to 2 pi. That is the theta. So if I integrate it, so from 0, okay, theta is, this is r theta, then this is, I'm sorry, if this is r theta, then this is r d theta, and this is dr. R d theta dr, integration theta 0 to 2 pi full angle, and r 0 to a. Now first I have to integrate kind of d theta. If I integrate d theta, then it becomes theta 0 to 2 pi. So it will become 2 pi, not 2 pi. And here it is r. If I dr, r square by 2, that will become r square by 2, where r is 0 to a square by 2. It will become pi a square. That is the area. So area of, so this is the, so now we'll go back to the, this is the one way we calculate the kind of surface area. If I calculate the surface area, means area of a circle. There is another way of calculating, that is the most basic way. Okay, that is the powerful way, where we don't go with infinitesimal space. This is what I kept talking. That calculus is not approximation. So what is now we found that there are two orthogonal components. One orthogonal component is radius, another is perimeter. So what is the equation of the perimeter? The equation of perimeter is r theta. Okay, if I go theta degree, then it is r theta. If I r theta, if I go along radius, then that is r. That is a. The full radius is a, and arc. If I calculate the arc, then it is then arc. Then it is r theta. Okay, a theta. If this is full, it is full a. If it is full a, then it is a theta. A theta. Okay, and if it is a, if it is then a, so one direction it is radius direction, x-axis, like we take x-axis and y-axis. If I see Cartesian coordinate, what we are trying to find here, if I have collection per hour, collection per hour is the algebraic equation. If I integrate with the r, I get the net collection. So collection per hour is algebraic equation where independent component is hour. If our independent axis is t, that is hour, then I have to get collection per hour as a function of t. Ft, function over t. If I get that algebraic equation, then if I draw this algebraic equation, I try to get the area, I get the net integration. I don't have to do dA and dx and dy. Nothing is required. X-axis is t, then function over t is the algebraic equation. If I have algebraic equation, if I calculate area of the algebraic equation against the t-axis, that area is the integration. So we have to find the algebraic equation if I want to find the area. Okay, algebraic equation is nothing but d area by t independent component. So what? So area is nothing but, if we see the area is nothing but multiply of two independent components. So first is the arc, and second thing is radius. There are two independent components. One is radius. Radius will keep growing, and one is arc. Arc means angle. So angle is independent component, it will move in its own way, and radius is independent component, it will move in its own way. Then what is the algebraic formula in terms of radius? That is a. And what is algebraic formula in terms of theta? So this arc distance is a theta. Now we have, now theta, that theta is one independent component. Here a is one independent component. So algebraic equation on one side is a theta, means a, theta being independent component. So the function over theta is a. Here function over a is 1 into a. Now if I want to calculate the area, the net function that results here is a. The net function that results here is a. Now a is the algebraic equation because we have to multiply these two. Dx and dy, if I multiply, I get the area. Here radius component and theta r component, these are two independent components. If I multiply these two, I get the area. So area is nothing but one algebraic equation is a theta, means a. Theta is independent value. Another is a, means the 1 into a. So a into 1, a is the algebraic equation. Now I have to integrate a. If I take out theta, if I take out theta and take out a on that side, then it becomes net collection per theta per radius. So if I have net collection per theta per radius, if I calculate the area of this with respect to theta and radius, then it gives me the net area. So the integration of a with respect to d theta and dA, that is required. So what is integration of theta is 2 pi. So a into 2 pi. Now this integration with a is a square by 2. So pi a square. There is no point in calculating d theta, dA and r d nothing. Just find the algebraic equation in terms of the velocity wave. Means if I have collection, kilometer collection per hour, that is the function. You have to find algebraic equation that is rate of change with respect to independent component. Once you have the algebraic, concentrate on the flesh, concentrate on the meat. So if you concentrate on the meat, fruit flesh, so concentrate on the fruit flesh, then you will get the rate of change. Once you get that algebraic equation, and then you integrate the algebraic equation over the these independent variable, you get the net collection, net area. Okay. Anyway, we calculate the surface equation, that is the square root of fx square plus fy square plus 1 d, the closed circular region. The closed circular region in polar coordinate is r d theta dr, r dr d theta. This is what we saw. This works for cone, sphere, paraboloid who makes in xy plane as a closed circular region. Then we saw same spherical surface area through a spherical coordinate. This is our invention that we are going to file at least a kind of disclosure on how to calculate surface area of a sphere, that is hybrid model of Cartesian coordinate and a spherical coordinate, that no one has done it. So that is now the concept that is coming, the concept that is coming now, that can we calculate the surface area of a sphere in full, surface area of a sphere in surface area of a sphere in full spherical coordinate. That is the concept. What is a spherical coordinate? If this is a sphere, consider this is a football and this is a sphere, then if this is z-axis, this is x-axis and this is y-axis. This is x-axis, this is y-axis and this is z-axis. If it is true, then this is radius. This is a sphere. This is xz plane of sphere. This is yz plane of the sphere. This is xy plane of the sphere. Everywhere radius is a. Everywhere radius is a. Everywhere radius is a. It constitutes a sphere. If I take a radius that is phi angle from z-axis, then this radius makes phi angle from the z-axis. Okay. Now, what is this radius? What is the component of this radius along z-axis? Radius a cos phi. If it makes phi angle from z-axis, then a cos phi. If this is a cos phi, then a sin phi falls on the xy plane. If a sin phi falls on xy plane, then a sin phi cos theta is x-axis. A sin phi sin theta is y-axis. So A's component along z-axis is a cos phi. A's component along xy plane is a sin phi. A sin phi cos theta is A's component along x-axis. A sin phi sin theta is a component along y-axis. Okay. Now we go with the bookish way. Through bookish way, I have to calculate the full surface area. In this surface area, I'll take a small dA. Okay. So if I have a surface area, if this is a sphere, then full surface area, I take a small dA, a small area on the surface. If I have an area, means it has two sides, width and height. Okay. So height side, if I take a smallest, let's say that this angle I had taken, the angle I had taken from the vertical is phi, then phi is 90 degree. Now it is full xy plane. If it is xy plane, then what is the, now if I take a small area on the surface, then this is one side of the surface and this is another side of surface. One side of surface is xy plane and another side of the surface is either xz plane or yz plane, something like that. So what is xy plane? What is the arc? Arc is a sine theta d theta. If I take theta angle here, then a sine theta d theta is the arc length. What is this arc length? That is a d phi. If this is phi angle, then a d phi, that is the vertical arc. Horizontal arc is a sine theta d theta. The surface area is a sine theta, a sine phi d theta, a sine phi d theta, a d phi is the dA. Now I have to integrate phi from 0 to 2 pi, 0 to pi, and theta on the xy plane that I am rotating 0 to 2 pi. So it results in a sine phi d theta and a d phi, that will become a square sine phi d phi d theta. So a square is constant, sine phi becomes integration of sine phi becomes cos phi minus cos phi, cos phi. Now if I cos phi, if I place the limit from 0 to pi, this would result in 2, value of 2. If it results in value of 2, then d theta, if I integrate 0 to 2 pi, then it would result in kind of 2 pi. So 2 into 2 pi, 2 into 2 pi would become 4 pi. And here a square, 4 pi a square. So 4 pi a square is the surface area of a sphere, a spherical coordinate. Now let's take the power of calculus, that is integration. In integration, I have to find rate of collection per independent component. So one independent component is theta and another independent component is phi, where radius is always a, because we are calculating the surface area. If radius is a fixed, then phi angle from that is variable, it varies like this to calculate the surface area. And theta on the xy plane, it varies like theta and phi are two independent components. If that is true, then what is algebraic equation we see when we calculate, we vary the theta? That is a into theta. Okay, so a here, a is not this a is this is. Okay, so if this is a, this is phi, then a sine phi is the actual radius here. So a sine phi, a sine phi theta, a sine phi theta is the actual, the kind of algebraic equation that we see here. If I miss the full component, full length we are seeing, if length we are seeing, then we have to find the change d length by d independent component, net collection by net independent component. If it is a sine phi theta, where theta is independent component, theta I have to cut down. Okay, so actual algebraic equation that is in velocity vector is a sine phi. Now this is this side. Now this side arc, one side arc, if I say in xy plane, I get the algebraic equation as a sine phi, where the independent component is theta. Now if I see this arc, that is another arc that is in variation of phi, then here it is a phi, here it is a sine phi theta, then here it is a phi. Okay, if I move phi degree, then it gives me the arc. So equation is a phi, but I have to get rate of change, velocity vector, then it is a. Now a sine phi is one algebraic equation along the independent component theta, and a is one algebraic equation along independent component phi. So if I multiply these two, this arc way and this arc way, if I multiply these two are independent component for the area. This area and this area. These are two independent components of the surface. Surface has two independent components. Line has one independent component. Now, if I multiply these two algebraic equations, A sine phi A, where the independent components are theta and phi. So this algebraic equation A sine phi A square sine phi is the net algebraic equation that is nothing but change in the area per theta per phi. This is what is the velocity vector. Change in means area per theta per pi, like collection per hour. Now, if this is the algebraic equation against theta and phi plane, there is a new plane, hybrid plane is coming, that is called theta phi plane. So if I have one axis, that is theta phi plane, and I have algebraic equation against is, that is area per theta phi plane. If I calculate this algebraic equation underneath area, I get the net area, that is a square sine phi. That is the equation d theta d phi. That is the independent components. That is the d theta phi plane. This is the actual calculus where we are not taking any d theta d phi, nothing. Or rather, I can remove d theta d phi completely. And now I have a function over theta and phi as far as area is concerned. That is a square sine phi. That is d area by d theta phi plane. That is a square sine phi. This is our way. This is actual calculus way. A square sine phi is the algebraic function. Whenever you are trying to calculate integration, try to fetch the flesh, fruit flesh. What is the actual function? Okay, once you get the actual function, then calculate the area of this function against the independent variable axis, and then that area is the net collection per independent component. An independent component is theta phi plane. Theta phi plane is the independent component, not theta, not phi. Theta phi plane, and where the net collection, that is area collection per theta per phi, that is the algebraic equation, that is sine square phi a square sine phi. Now simply calculate the integration of a square sine phi. So a square is constant, so sine phi. So first sine phi integration over the axis, that is theta phi plane. So theta phi plane means we have to do integration one by one. So with the phi, it will result in cos phi. Same thing. Now phi moves from 0 to pi, then it will result in 2. So 2a square. Now I have to integrate. Now rest is 1. So 1 remains. So 1 is nothing but theta 0 to 2 pi, so 2 pi, so 4 pi a square. That is the integral surface area. One we calculated through d theta d theta dr. Then we spanned it over full sphere. One we calculated, one which first we understood what are the independent components. Along the independent component, we found the algebraic equation. We multiplied the algebraic equation along the independent component. What is the algebraic equation for which we are calculating the net addition or area? So those two algebraic equations we found, we multiplied, and then we calculated the area of this algebraic equation in terms of limit as theta and phi. No need to place d theta d phi at all. Sine a square sine phi, integrate it along the, calculate the area along the independent axis, that is hybrid plane of theta and phi. Okay, so we calculated the surface area of a sphere, that is 4 pi a square, in terms of the spherical coordinate. You remember we did not do fx square plus fy square plus 1 square root that we initially calculated through Cartesian product. we had a position vector and xi plus yj plus zk dfx by dx d I mean dp by dx dp by dy cross product. Then if I do cross product, then I calculate the cross product. If I do, then we get the area dp by dxy plane. Magnitude is fx square plus fy square plus 1 square root dx dy. Okay, so that is something that we did not go through. First, we went through a spherical coordinate system. So spherical coordinate system, if we went through, then we pure first way we calculated the dA and dA, we integrated over the phi and theta. In second way, we focused on the algebraic equation, not on the D. These are two ways. We will, whatever we are talking, whatever the way, for every video we will have presentation disclosure. This is what the idea. If we have 300 video in calculus area or 200 video, 250 video, then 250 disclosure we will file. That's why we are saying that we are going to file 1000 to 2000 disclosure in next 6 months or 1 year time. So 250 or 300 is already over. Only thing we have to document. So this is the two-way pure spherical coordinate way. Pure spherical coordinate way means not taking the consideration of Cartesian coordinate at all. No hybrid way. So hybrid way we have seen spherical Cartesian hybrid, polar Cartesian hybrid. This is pure spherical coordinate way that we calculated the sphere. Okay. Now what would be the, now there can be use case. Suppose that I am making a water tank. I am making a water tank, and water tank is hemisphere. Water tank is hemisphere of radius A. For radius A, water tank is hemisphere. Now at height of h, I cut the water tank. Above it, I am not making it. Okay, there is a hemisphere at height h. I have cut down. Above, I am not making the water tank. And flat area I have covered. Suppose full I am making with the steel. Full I am making with a sheet of steel. Hemisphere little bit up at height h. I cut it down, and there I covered with a circular steel. Circular steel and half of the hemisphere steel, where radius is a and height up to h. I cut it down. How much area? How much area of the steel I need? That is the question of this video session. So this video session has a questionnaire now, that if I have a water tank that is in hemisphere nature, half of the sphere, where the radius is a, but when, so it will have height of a, width of 2a and height of a in hemisphere fashion. But when it reaches height h, 1h, height h, it can be a by 2, a by 3, a by 5, or 3a by 4, whatever. If it reaches height h, up to there only I am constructing the water tank. Above that I am not constructing. That top area I am covering. Now I am covering with a iron sheet, and this is also iron sheet. What is the area of the iron sheet I need? I need to purchase. If iron sheet is 10 kilogram per square meter, then how much is the weight? How much is the weight of the iron sheet I have to pay for? Okay, so that is the question. Okay, so what is the answer for it? So probably you can try. So I would tell the answer also. So answer is, if I have a hemisphere, then I have to calculate the surface area. Surface area of the hemisphere. Now surface area of hemisphere is a square sine phi. A square sine phi. Now if it is a square sine phi, then there are two variables. One is phi, that is 0 to pi by 2 hemisphere. But it is not 0, it is from some angle to pi by 2. Whereas this theta is 2 pi. straightforward. Okay, this is pure spherical coordinate where phi is from 1 pi to pi by 2. This is the limit, whereas radius is full 2 pi. So this is one way of calculating the surface area of the hemisphere, not the top region I am covering with a circular region. So that is simple. That can be found. Okay. Now there is another way. There is three way. This is first way. Second way is hybrid polar and Cartesian coordinate. So hybrid polar Cartesian coordinate is we have fx square plus f square plus 1 square root and then dxy plane. If dxy plane, that is the closed circular region, that is r d theta dr, r d theta dr. Now I have to integrate r from 0 to a and theta 0 to 2 pi. If that is the case, then r, I have to start not from 0, I have to start from where there is air, where the if it is hemisphere, where it stops. At that position we have the r. So I will start the r from here till a and angle full 2 pi. So I have to integrate fx square, that came as, I remember, a by square root of a square minus x square minus y square, fx square plus fy square plus 1 square root d of the closed circular region, that is r d theta dr, r d theta dr, where x is a, x is r cos theta and y is r y theta. Then r d theta dr I have to integrate, where r is from one region to a. One region is, if I make hemisphere stops here. If I close it, then r starts from 0. If I stop here, then r in this circular region, r starts from one location. That location to a, that is the limit of r, and then theta full 2 pi. This is Cartesian coordinate polar hybrid. We talked about Cartesian coordinate spherical hybrid also, if you remember it. So then in that, the r, it is same as r d theta dr, what we are talking, but x is here now a sine phi cos theta, y is a sine phi sine theta, and z is a cos phi. If that is the case, then r d theta dr, r is a sine phi. Okay, r is a sine phi d theta, where dr is d of a sine phi, that is cos phi d, cos phi dr, a sine phi, a sine phi, d of a sine phi, that is a cos phi d of phi. Okay, so that turns to d theta d phi. So that will turn into a square, a square, a square sine phi, a square sine phi d theta, a square, a sine phi d theta will turn up a sine phi is r d theta. So a sine phi d theta, a sine phi d theta, a cos phi d phi, a square sine phi cos phi d theta d phi. This is our way, that is disclosurable, and now the d theta and d phi. So theta is full 2 pi, where phi is again from one closed open region. If it is hemisphere, then it is not closed, then from where it is open, from there to the pi by 2. Okay, so this is what is three approach. We have given the solution. Please watch all the session and come up with the solution, that what would be the net steel that is required to make a hemisphere with height h and radius a, and then full closing it. And if there is a $10 per square meter of the steel cost, $10 per kg, 10 kg is the steel, that is required to make 1 square meter of the sheet, then how much kilogram of the sheet is required, so that someone can buy from the shop as far as the kilogram is concerned. So now in next session, we will see more in the calculus, probably the line integral, flux integral, curl integral, parametric integral. So those things are still away. So those things we will see. So we'll proceed in the vector area. So now algebraic area era is not over, but now algebra and vector hybrid model, that is the future, because we need direction. So not only algebra point by point will work, every point has a direction. So vector field, that is hybrid model of vector and algebra, so that is considered a future of the algebra till now. So that we will proceed on that. So we end up this kind of surface area calculation in circle and 3. We calculated for the cone, sphere and paraboloid with many ways. So now we will proceed further.